In this video, we will look at closures as a possible cause for memory leaks and how we can detect them and possibly even avoid or fix them. Hi, I'm Rohan and this video is part of a series of videos where we are exploring how JS manages its memory in depth. More specifically, looking at various use cases that are the common causes for memory leaks and how we can understand and avoid these types of coding patterns. So let's get to it. Let's understand how closures can cause memory leak. But before that, we need to understand how function scoped variables work. So when we have variables scoped within a function, once the function finishes its task and exits the call stack, if there are no references to these variables outside of the function, then they get cleared out. Till here, it's pretty straightforward, right? But closures work a bit differently. They hold on to these variables, keeping them alive even after the function has completed its task. It's important for us to be mindful of this behavior since we have to manage memory and flow of data within our code. Let's look at an example. In this example, we have a function called calc_square. In this function, we have a variable that has a property value and a getter property square that calculates the square of the value. And the function returns an object that has two functions, set and log. Set function sets the value and log functions logs the data. Since we are going to run this in the Node.js context, we are going to use process.memory usage. From that, we are going to log the minimum, maximum and the current heap usage in megabytes. Now, outside of this function, we are going to run a big loop, inside of which we are going to run calc_square and after that set and log. Let's run this. And in the logs, we will see that the memory used by the heap is progressively increasing. This type of progressive memory consumption is bad and this indicates that there is a memory leak. Now imagine if we increase the size of the loop exponentially or if this piece of code is part of a larger application. Let's try to reproduce this in the browser. So we will tweak our code a little bit. We will create an HTML file. In this file, we will have a button. We will also have our piece of code as an internal script in this file. We will remove process.memory usage as it is Node.js specific and we will see the memory usage in the performance section of the DevTools anyway. So the code remains mostly the same. But this time, instead of running a big loop, we will instead run a bunch of smaller loops whenever we click on the button. After that, we open a Chrome tab with this file. Then we right click, click on inspect and go to the performance section. There, click on the record icon and then start clicking on the button periodically. After some time, we will stop the recording. Let's focus on the net heap chart, which is showing a progressive increase in the memory, which indicates that there is a memory leak. We can also focus on a particular section, which shows a sudden bump in CPU consumption, which means that at this point in time a click event happened. And if you notice, we can see all the parts of our code that are being run, and this sometimes include minor garbage collection. So seeing this chart which shows us a progressive increase in the net heap memory, we can safely assume that there is a memory leak. So how do we fix this? If we go back to our code and focus on the click event, we can see that on every click we are running a loop. And in each iteration, we are calling calc_square. So for every click event and for every iteration, we are creating more and more closures, which is not good. And we have to fix this. Our aim should always be to reduce the amount of closures being created. To accomplish this, we need to move line number 31 outside of the click event. This way, there is only one closure being created, but the result stays the same, which is excellent for our use case. Now, let's open the tab again and go back to the performance tab and record a few seconds of click events. And you can immediately see that the memory consumption is minimal and it's fluctuating between two small values, which is what we wanted. Now, I have to confess here, this example was easier to fix because I knew exactly what the issue was. But this is not the case every time. More often than not, there's a lot of code and closures are happening all over the place. And we have a vague idea that there may be a memory leak somewhere. So the goal should always be to analyze our code, the closures that are being created per function call, the objects that are being retained by the closure, and to keep an eye on the overall memory consumption. Understanding this process can help us avoid unexpected issues and maintain a cleaner and much more efficient code. So to quickly summarize, we saw closures as a source of memory leaks using a couple of examples and how exactly we can fix them. In the upcoming video, we will see timers as potential sources of memory leaks. If you have liked this video, consider liking and subscribing. Thank you for your time. Have a nice day. Namaskar.